Okay, hi, this is Mr. Medic. I'm going to show you how we're going to do 1.8 classwork. So I'm going to read this. It says, describe how to find the next term of the sequence. Write the recursive rule. Describe how the features identified in the recursive rule can be used to write an explicit rule, and then write an explicit rule for the function. And finally, identify whether it's arithmetic, geometric, or neither. Well, as I look at this sequence, I notice that this says 5 for an output and this says 10. Now there's two different ways I could get that. One would be to add 5, another would be to multiply by 2. So let's look at the next one, which says 10 and 20. Well, to go from 10 to 20, I'd have to add 10. Well, that's different than the first one, so I don't think that's the rule. But multiplying by 2 also gets me 20, so that's the rule I'm looking for. We're multiplying the previous term by 2. Let's see if I can make that sit a little better. Oops, no, that's pretty good. I like that. Okay, now the recursive rule is related to that. Now we've learned that the recursive rule looks something like this. I can get this thing to write. F of n is equal to f of n minus 1 times, in this case, 2. That's a recursive rule. That's an easy rule. I'm trying to get this to not be on that line, but I don't think that's possible at this point. Okay, so now how do you find the nth term? That's the same thing as asking what is it that you do to get the explicit rule. There's an idea. I could switch it this way. Okay, to find the nth term, we would let's see, starting with 5, multiply by 2 to the power of the next term. So for example, let's see what that looks like. I'm really having trouble with this. Okay, so the explicit rule here is going to be f of n equals, now see, it's starting with 5, so we're going to go 5 times, and then this is the common ratio, which is 2. And now I wish I could put an exponent in this, but it won't let me, so I'm going to instead put the caret, which means this is the exponent coming next. This is what the caret looks like. And I have to put it in parentheses when I put it like this because I got to write more than one thing in here, specifically n minus 1. Now if this works, I should be able to put 1 in here and get 5. Put 2 in here and get 10. Let's see if it works. Well, if I put a 1, I get n minus 1, which is n, which is 0, and 2 to the 0 is 1, and that times 5, yep, gets me 5. Let's see if we get a 10 when we plug in a 2. If I put a 2 in here, I get 2 minus 1, which is 1. 2 to the 1 is 2. 5 times 2 is, yep, it's 10. I think that's the rule. And because we're using a common ratio, this is pretty clearly, let's see, I'm going to pick draw because it's easier to draw. How about that? It's a geometric sequence. And it's a geometric sequence because we've got a common ratio. Specifically, when I go from this one to that one, I'm multiplying by 2. So that makes it geometric. And that's how you do the classwork.